Welcome back, folks. This is the last part 4, for Chapter 8, or Module 8. This is all about doing hypothesis testing for a standard deviation. So we've done a proportion, we've done a mean, and now we're doing the standard deviation. If you remember, the standard deviation involves something called the chi-squared. Statistic that we'll be using is chi-squared n-1 sample standard deviation squared over the population standard deviation squared. Now, the calculator doesn't do this one for us. We have to actually do this one manually, which is fine. There are two questions with data. I've already preloaded those into my calculator. So if you want to pause the video and do that, I'm going to go ahead and get started here. So example 11, listed below are the heights for the random sample, simple random sample of supermodels. Will we use a 0.01 significance level to test the claim that supermodels have heights with a standard deviation that is less than 2.6 inches for the population of women? Let's start with our null hypothesis. Is that the standard deviation is 2.6. Remember, it's always equals. The alternative is the not equal ones. And they're saying that the standard deviation is less than 2.6. It's going to give us a left tail. Now remember, chi-squared graphs look different than a T or a Z. We skewed a little right. And because it's less than, it's going to be a left tail. And remember, chi-squared starts at 0. That's different than the T and the Z as well, that go from negative infinity to infinity. Let's mark that. That's a 0. And the area here, 0.01. So let's get our critical value. And for that, we need our chi-squared here. So if you remember, this represents area to the right. We have area to the left. So if 1% is here, that means 99% is over here. So we need to also establish the degrees of freedom. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. So n equals 10, which means our degrees of freedom is 9, with an area of 0.999, or 0.99, pardon me. Degrees of freedom is 9. That is here. And 0.99 is here. So that gives us .99, yeah. Degrees of freedom is 9. .088. Sorry, my eyesight isn't so great. 2.088. All right, that is our threshold. And we are now going to get our test statistic, but we're going to have to grind it out. So we have chi-squared. And here's the thing. We don't have our standard deviation. So we're going to go back. And as I said, I put mine into list 1 here. There's the 70 and the 71 and so on. And I'm going to run stat one variable statistics on list 1. Remember, if you don't know how to change it from whatever list is there, or maybe it's not there at all, you go to above the 1 is L1, L2, L3, L4, 5, 6, and you have to hit second in the list that you want. I'm in list 1, and I'm going to hit go. And S is right there. So let's write that down. So this is 0.7997. So our chi-squared is going to be n-1, which is 9, times 0.7997 squared over sigma squared, 2.6 squared. And let's do this. 9 times 0.7997 squared divided by 2.6 squared. And I'm getting 0.85. 0.85 is going to be about there. Now, if I want to get the p-value, meaning the area to the left here, the p-value is going to be chi-squared CDF, and it's going to go from 0 to, what is that? Not 2.88. We're going to go from 0 to here 0.85 with the degrees of freedom of 9. Let's see what we get. So distributions, chi-squared CDF. Lower is 0. Upper is the 0.85. Degrees of freedom is 9. Ooh, so that is a very, very small number. So this is about 0. Now I'm going to show you what I'm doing here. I'm going to move that decimal 4 places to the left. So that means there's going to be 3 zeros and then the 2. 1, 2, 3, 2, 8, 7, 6. And the point is, this is way less than my alpha, which is 0.01. So we are going to reject the null hypothesis. So there is sufficient evidence to support the claim that the supermodel's standard deviation is less than 2.6. So notice I'm not saying that I'm accepting the alternative hypothesis. I'm saying I can reject that they are the same, and now maybe there's something different. All right. Number 12. Again, make sure you take a minute, pause to put those in. Mine are in list 2. So when I do my stuff, I'm going to use list 2. Listed below are speeds, miles per hour, measured from southbound traffic. Use 0.05 significance level to test the claim of the highway engineer that the standard deviation of speeds is not equal to 5 miles per hour. So my null hypothesis is that the standard deviation is 5 miles an hour, and the alternative is that it's not 5 miles an hour. So I'm going to draw a graph. Now notice not equal to equates to us as a two-tail. All right, again, remember that starts at 0. And our alpha is 0.05, so this is going to be 0.025. 0.025. So we're going to end up with 2 of them. Now I want to remind us that in the middle here, this is 0.95 because we need area to the right to get that. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces of data. So n is 12, which means our degrees of freedom is 11. And area to the right on this one is going to be 0.975. When I add that plus that, it's 0.975. Let me demonstrate that for you. 0.95 plus 0.025. 0.975. Degrees of freedom is 11. So we're there, and I already forgot. Is 0.975, that's right, 0.975. So we are here, 3.816. 3.816. Area to the right here is 0.025, same degrees of freedom, 11. 0.025, 11. We are here 21.920. All right, so now let's find our test statistic. Chi is going to equal 11, and I don't have S yet. So I'm going to run one var stats again, but on my list 2 in this case. So stat calculate. So I'm going to change that to list 2. So I'm going to hit second. That changes it to L2. Calculate that, and there is my S. So S is about 4.075. Over 5 squared. All right. So here we go. 11 times 4.075 squared divided by 25. This gives us 7.306. That's about right there. Notice we are not in the critical region. Yay. So we're going to fail to reject the null hypothesis. So there is not sufficient evidence to support the claim that standard deviations are not equal to 5 miles per hour. And that, ladies and gentlemen, is chapter 8.